Hi guys! So welcome to another episode of Learn with Sir Glenn. So today I'm going to teach you how to solve for the nth term of geometric sequence. So let's go! So before we proceed with the topic, let's have a drill first. Determine the next term of the given geometric sequence. The correct answer is 64. The next one. Determine the next term of the given geometric sequence. And the answer is 54. Now the next one. Determine the common ratio of the given geometric sequence. The correct answer is 5. So r is equal to 5. You can get it by dividing consecutive terms. So 10 divided by 2 is 5. 50 divided by 10 is 5. Let's have the next one. Determine the common ratio of the given geometric sequence. The correct answer is negative 3. If you divide the consecutive terms, you will have 9 divided by negative 3 is negative 3. Negative 27 divided by 9 is negative 3. 81 divided by negative 27 is negative 3. Okay? So obviously, finding the next term of your geometric sequence is easy. So as long as you have the common ratio, you multiply to the terms, then you will have the next term of your geometric sequence. But what if you are going to look for a specific term? Let's say you want to look for the 15th term, 8th term, 10th term of your geometric sequence. So for that, we're going to use the formula for the geometric sequence. So solving for the nth term of geometric sequence. So we're going to use the general rule of geometric sequence, which we discussed on our previous video, which is a sub n is equal to a sub 1 times r raised to n minus 1. For this one, the a sub n will be our missing term, the a sub 1 will be our first term, and r will be the common ratio, and n will be the position of the missing term or the nth term or the a sub n. Okay, so how to use the formula? So let's say you want to solve for this one. 1, 2, 4, 8, then you're looking for the 10th term of the sequence. So instead of writing down every term, you can just simply use the formula a sub n equals a sub 1 times r raised to n minus 1. So before we can use this, you have to identify first the variables on the given general rule. So the a sub 1 is the first term, so for this one it is 1. The r is 2, which is the common ratio. Then n is equal to 10, which is the position of the missing term, a sub n. So after finding the values of those variables, we're going to replace the variables with the given values. Therefore, your a sub n will become a sub 10, your a sub 1 will become 1, your r will become 2, and n will become 10. So your equation will be a sub 10 is equal to 1 times 2 raised to 10 minus 1. Then we're going to solve this using PEMDAS. So we will have a sub 10 is equal to 1 times 2 raised to 9, subtracting 10 minus 1. Then we expand the exponent, so we will now have a sub 10 is equal to 1 times 2 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 times 2, expanding to raised to 9. So be careful with this one. The common mistake of students, they multiply the base and the exponents, so which is wrong. So what we're going to do is to expand your exponent, you're going to multiply the base the same number as the exponent. So that's why you will have here 9 2's. Okay? So multiplying this will give you a sub 10 is equal to 1 times 512, which is equal to 512. So the 10th term of the sequence is 512. So let's have another example. Let's say you want to find the missing term of the given geometric sequence. So let's say you have 3, 6, 12, and then you want to find the 8th term. So again, we're going to use the same general rule, which is a sub n is equal to a sub 1 times r raised to n minus 1. Then we're going to look for the values of our variables. So obviously, a sub 1 is equal to 3. R is 2. You can obtain that by dividing any consecutive term, such as 6 divided by 3. Then we have n is equal to 8, because we are looking for the 8th term of our geometric sequence. So after this, we replace the variables with the given value. So a sub n is equal to a sub 8. A sub 1 will become 3. Then r will become 2. And n will become 8. So we now have a sub 8 is equal to 3 times 2 raised to 8 minus 1. Then we're going to solve this using PEMDAS, parenthesis, exponent, multiplication, division, addition, and subtraction. So we will now have a sub 8 is equal to 3 times 2 raised to 7, which is 8 minus 1. Then after this, we're going to evaluate the exponent. So we will have a sub 8 is equal to 3 times 2 times 2 times 2 times 2 times 2 times 2 times 2. So notice that I'm using now a parenthesis instead of using the cross symbol for multiplication, because sometimes you might encounter a variable x on your sequence, then this will be confusing with the x multiplication sign. So what we're going to do now is to multiply the numbers. Then you will have a sub 8 is equal to 3 times 128 or equal to 384. So the 8th term of the sequence is 384. Okay? Okay, so let's have our last example. So find the 10th term of the given geometric sequence if a sub 1 is equal to 128 and r is equal to 1/2. So although your problem is presented in a different way, we're going to use the same general rule for this one, which is a sub n is equal to a sub 1 times r raised to n minus 1. And the same process, we have to identify first the variables on our general rule. So we will have 1/2 is equal to 128, which is on the problem. R is equal to 1/2, which is also in the problem. Then n is equal to 10, because we are looking for the 10th term of this geometric sequence. So after this, we're going to replace the variables with the given value. So we will now have a sub n will be replaced by a sub 10, because we are looking for the 10th term of this geometric sequence. A sub 1 will become 128, r will become 1/2, then n will become 10. So you will now have a sub 10 equals 128 times 1/2 raised to 10 minus 1. After this, all we have to do is to solve this using PEMDAS. So we will have a sub 10 is equal to 128 times 1/2 raised to 9, which is 10 minus 1. Then we're going to expand the exponents. So we will have a sub 10 is equal to 128 times 1/2 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 times 1/2. So expanding 1/2 raised to 9. So all we have to do is to simplify it further. So we will now have a sub 10 is equal to 128 times 1 over 512. So you can multiply the numerator to numerator, denominator to denominator, then simplify. Or you can also use cross cancellation. So since 128 and 512 are both divisible by 128, we divide them both by 128. So 128 divided by 128 is 1. 512 divided by 128 is 4. So therefore, our answer is a sub 10 equals 1/4. So how to solve for the nth term of your geometric sequence? It's going to use the formula a sub n is equal to a sub 1 times r raised to n minus 1, where a sub n is the missing term, a sub 1 is the first term, r is the common ratio, and n is the position of your a sub n. So that's it. We're done. Thank you for watching and hope you have learned something from this video.